In this lesson, we are going to analyze nitrogen dioxide molecule. First, we will draw the skeleton of NO2 molecule. So, there are three atoms we can see here: oxygen, nitrogen, and again oxygen. Each two oxygen atom can give 6 electrons for the bonding. So there are 12 electrons, and nitrogen can give 5 electrons for the bonding. So altogether 17 electrons. So then we can complete the octet of 2 oxygen atoms since they are bound to the center nitrogen atom. Now we used 16 electrons, so 17 minus 16 is equal to 1. That means 1 electron is available for center nitrogen atom. So this is a special case. In most cases we can see lone pair electrons are on the center atom, but here we cannot see that as a lone pair, but we can tell that as lone electron. It means that that electron doesn't participate in bonding. We can check whether the nitrogen atom has completed its octet. So far, then this nitrogen atom has 5 electrons, because there are 2 sigma bonds. It will add 4 electrons, and this one isolated electron with it add up to 5 electrons. So then we can take 2 from here. Now 4 electron, 2 electron, and 1 electron, so 7 electron. But we cannot take another 2 electron because then it will exceed 8 electron on nitrogen. Nitrogen cannot keep more than 8 electron because it doesn't violate the octet rule. So we have to stop from here. Then we can determine the charges of these atoms. So I'll write oxygen 1, nitrogen, and oxygen 2. So oxygen 1, 2, and nitrogen atom. So we will write the valence shell electrons of each atom. Then we can count the number of electrons belong to those individual atoms. So here 2, 2, 4, 2, 6. Here 2, 3, 4. Here 7 11. So we can see 0, minus 1, plus 1. So this will give plus 1 and this will give minus. So even though there are charges, when we consider the total molecule, it doesn't have any charge. So it is a neutral because these positive and negative charges will cancel out. Now we can move into the oxidation numbers. First we will consider this oxygen atom number 1. Oxygen is more electronegative than nitrogen atom. So if we consider the double bond here, oxygen can withdraw the electron cloud toward itself. So these are covalent bonds. So oxygen feels 2 extra electrons come toward itself because oxygen atom attracts the electron cloud in this double bond. So oxygen gets extra negative charges. So magnitude is equal to 2. When we consider this nitrogen, it loses 2 electron from here and 1 electron from here, then 2 plus 1 3 with this positive charge is 4. When you come to this one, again minus 2. Now let us consider the geometry of the molecule. So because of this 1 electron on the center nitrogen atom, it creates some repulsion between bonding pair electrons. So this molecule take bent shape. Now we will move into to consider the hybridization of each atom. In previous videos I have given detailed explanation on hybridization. So if we consider oxygen 1, there are 2 lone pairs and 1 sigma bond. So we have to have 3 hybridized orbitals. That means it is sp2. When you consider oxygen atom number 2, 3 lone pairs and 1 sigma bond, so we have to have 4 hybridized orbitals. So it is sp3. Means that 1 s orbital and 2 p orbitals mean it adds up to 3 hybridized orbitals. Here 1 s orbital and 3 p orbital mean it adds up to 4 hybridized orbitals. Now we will consider the hybridization of nitrogen atom. So we can see there are 3 electrons in p sub-energy level and 2 electrons in s sub-energy level. So when we consider this nitrogen atom here, it has positive charge, and in its valence shell there are only 4 electrons, 2, 3 and 4. But ground electron configuration, it has 5 electrons. So we have to rearrange so it accurately connect with this situation. It is accurate to remove this electron because it is energetically more favorable than removing the p electrons. So once it is removed, you can write like this. So here 1 sigma bond, another sigma bond and 1 electron. So we have to have 3 hybridized orbitals. So we can take 1 from S and 2 from P as sp2. So 1 electron remaining with p orbital, it is used to create the 5 bond. So this is the final result. Oxygen atom number 1 and nitrogen atoms have sp2 hybridization. Oxygen atom number 2 has sp3 hybridization.